Dear students, in today's session, we will understand the very important part of the electrosynthesis, that is, laboratory cell design for the electrosynthesis. So, this is session 4 of electrosynthesis chapter. Myself, Dr. Ganesh Acharya. So, in the laboratory cell design, it is very important to consider the aspects with respect to how to construct a synthetic cell or electrolytic cell for the preparative purposes. Now, laboratory cells for the preparative electrolysis may have various designs, like it may be divided or it may be undivided, or it may have two electrodes or it may have three electrodes, or it may consist of a single electrophore, means a functional group, or it may consist of a reactant with multiple electrophores, means multiple functional groups, and so on and so forth. Now, in all electrosynthetic cell design, it may be having of the type static, or it may of flow type, means in the static type there will not be continuous flow of the reaction mixture through the cell. Okay, so while selecting a particular cell design, we have to consider the following aspects, like the selection of electrode material and the cell geometry. The selection of electrode material and cell geometry includes, first thing is electrode material and geometry of the cell, and selection in the geometry of cell. Once again, we have to consider the selection of electrode potential and preparation of the solution for electrolysis. This includes the solvents and supporting electrolytes, and also we have to consider the temperature and agitation effects. Okay, the fundamental aspects you have to consider while designing a cell for the synthetic purpose is electrode material, cell geometry, selection of electrode potential, and preparation of solution for electrolysis, and temperature and agitation effects. Okay, so you know that while selecting the electrode material, it is known that electrode is very important part of the cell, because only on the surface of a particular electrode the reaction occurs, means on the cathode there occurs reduction reaction, on the anode there occurs oxidation reaction. So in case of a one compartment cell, you know it is very important to consider the nature of both anode and cathode. It is of equal important. However, the working electrode is of more greater concern, because you have to select a working electrode depending upon the type of reaction. So working electrode is of greater concern, and the selection of electrode is actually depending upon what type of material you have to choose and its surface morphology. Okay, and while selecting a particular electrode material, you have to consider certain factors. One is, you should know the thorough knowledge, that is theoretical knowledge about a particular reaction. Say for example, you are considering a cold pair reaction. What you have to do, you are selecting a particular you know uh, carboxylic acid or an ester, and you are converting it to an alkane, right? So what are the steps involved in that particular reaction, that you should know. Similarly, in other cases also, you should know what type of reaction you want to carry out, and its theoretical knowledge you should know. And you have to carry out a particular reaction that is electrodic reaction using the same electrolyte medium under similar conditions. It is very important. You have to carry out reactions for several times under the same conditions, and you have to perform a voltammetry or polarography to study the current voltage relationship for a particular electrodic reaction. Okay, once you have to select the electrode, you have to perform the voltammetric studies or polarographic studies to get the current voltage relationship or IV relationship for a particular reaction on the selected electrode. Okay, now once you want to choose a particular material as an electrode, one thing you have to consider is it should be conducting, because only if it is conducting then there will be exchange of electrons. Then you can carry out either oxidation or reduction reaction on that particular electrode, right? And the electrode may be prepared from metals in the form of either it may be plates, rods, wire, gauzes, wool, sheet, or mercury pool, etc. And sometimes you are taking conducting polymer materials also, or sometimes you have to choose a conducting material like graphite, carbon, carbon paste, metal oxide, etc. Once you have chosen the electrode material, and once you have given a particular shape of the electrode, then you have to give a proper treatment to the electrode for the reproducible results. Okay, now it is important to consider the hydrogen over voltage while selecting the electrode material. Commonly used electrode materials are sometimes the anodic materials may be platinum, graphite, carbon, lead oxide, iron oxide, gold, or metals coated with rubidium, iridium, ruthenium, etc. And cathode materials may be mercury, lead, tin, zinc, cadmium, nickel, chromium, aluminium, graphite, etc. And hard metals like platinum, nickel, iron, copper has low hydrogen over voltage are also selected. Now it is very important to reactivate electrode from passivation for application in electrosynthesis. That means you should not have a passivated surface, means any compound formed upon oxidation which forms an inert layer on the surface, that should not be there while you are taking that electrode for electrosynthetic purpose. Now the cell geometry is another important aspect you have to consider. It is, in the cell geometry already we have discussed some aspects like the shape of vessels, positioning of electrodes, and geometric shapes of the electrode. These three are very important. That means you should consider a particular shape of the vessel and how to place the electrode inside the cell, and the shape of the electrodes. The shape of electrode should be very important to avoid the over oxidation or over reduction, so that if it is over oxidation or over reduction, the expected product will not be obtained. Therefore, the cylindrical electrodes generally are having equipotential surfaces in all directions. So therefore it is better to use cylindrical electrodes to get equipotential surfaces in all directions, and the undivided cells are the most convenient type of cells. Next is the electrode potential. Once you have selected a particular electrode and you have selected a particular geometry of the cell, then next step is to selection of the electrode potential. You know the electrochemical series of a particular element. Based on that you can tell whether it is more having oxidizing power or more having reducing power, etc. The rate of the electrochemical reaction and the nature of products formed are primarily determined by the electrode potential in all the electrosynthetic process. Therefore, the required electrode potential is fixed for a particular electrochemical reaction from the external source. Okay, how to choose the electrode potential? It is chosen and fixed by the theoretical knowledge of a reaction from the external source so as to oxidize or reduce a given reactant or substance. Generally, the activation energy modifies the, it is modified or it is obtained by the electrode potential. Okay, so this electrode potential modifies the activation energy barrier for a particular reaction. Okay, therefore, while selecting the electrode potential, you should consider the proper theoretical knowledge of the reaction and the potential of the electrode from the electrochemical series. And then you should consider either divided or undivided cells. Generally, undivided cells are better. The cell reactions involve oxidation and reduction. When these reactions do not interfere in any detrimental way, the one component cell or undivided cell can be used. Then next part of the cell is the electrolyte or solution. Why you have to consider this? It is because all electrochemical reaction needs a medium, generally a solvent. Okay, so once you have to dissolve a particular reactant in a solvent, then it is taken in the electrochemical cell. So all electroorganic reactions taking place in a liquid medium, therefore you have to choose a solvent. Then organic materials must be in solution in order to exchange electrons with the electrodes. Okay, because organic substances are not soluble in water. Therefore, you have to choose a particular solvent so as to carry out the reaction such that exchange of electrons can easily take place between the reactant and electrode. And the solvent must conduct electricity or it must have high dielectric current so that it can dissolve sufficient amount of electrolytes like salts, acids, bases to get more conducting solution. Okay, so you have to add some ionizable substances like salts, acids, bases, etc., which can enhance the conductivity of the solution, and they are called as supporting electrolytes. And once you use a solvent, it should not involve in the reaction. It is just have used to dissolve the chemical substance. The solvent should be electrochemically inert in a given potential range. Okay, and the function of supporting electrolyte, as I told you, to carry the current through the solution, and sometimes they may act as depolarizers also in a given potential range. Okay, you can choose the solvents, electrolytes, and you have to get particular voltage limit for cathodic and anodic reactions are tabulated here. Generally, the organic aprotic solvents means it doesn't have protons, often used as electrolytes like lithium chlorate, lithium chloride, lithium borofluorate, etc. Okay, now it is tabulated like this. In the solvent, you can take acetic acid, electrolyte, that is supporting electrolyte, sodium acetate, and the cathodic limit is minus 1.0 volts, anodic limit is plus 2.0 volts. Within this limit, you can carry out a reaction. And if you use acetone, you can use tertiary butyl ammonium chlorate that is having a limit of minus 1.0 to plus 1.6. And acetonitrile, you can use lithium chlorate as electrolyte. Minus 3.0 to plus 2.5 is the limit. And DMF, again you can use the same, tertiary butyl ammonium chlorate, that is minus 2.8 to plus 1.6. Methanol, again lithium chlorate, the limit is minus 1.0 to plus 1.3. And methylene chloride and pyridine and tetrahydrofuran. So these are the solvents and these are the corresponding electrolytes, and the respective electrode potential limits for the cathodic and anodic reactions are given here. Next is one of the important aspect to consider for the cell reactions is temperature effects, because the primary electroorganic reactions occur in the electrode electrolyte interface at a given particular temperature. Temperature obviously affect the reaction because it may form the adsorption reactions or diffusion reaction, enhances or decreases the diffusion rates or adsorption rates. So therefore you have to choose a particular temperature range. Therefore temperature affects the solubility of materials and it may affect the conductivity of electrolytes also. So therefore temperature effects are important in the electrosynthetic reactions. Next is agitation effect, because you know in all electrosynthetic reactions you have to bring the substance from the bulk to the electrode surface. Therefore the agitation should be considered to affect the mass transfer, and hence the rate of electrochemical reaction depends upon agitation also. Okay, so we shall stop it here, and we shall discuss the next remaining aspects in our next class. And as usual you can go through these textbooks to understand the selection of electrodes and selection of cell geometry and selection of solvents, etc.